Determine the values, if any, of such that the given system is consistent. For the system, x1 plus x2 minus x3 equals negative 2, x1 plus x2 plus x3 equals 0, x1 minus x3 equals 1, and x2 plus ax3 equals negative 9. Our first step in order of business is to convert this entire system into echelon form. We start this by subtracting row 1 from row 2, which allows us to cancel out the x1 and x2 terms, leaving us with 2x3 equals to 2. Next, we're going to swap row 2 and row 4 to further simplify to echelon form, which will leave us to get the x2 plus ax3 equals negative 9 in the second row, and the 2x3 minus equals 2 in the fourth row. Next, we are going to subtract row 1 from row 3 to continue converting to echelon form. This will lead us to get negative x2 equals 3 in row 3 instead of x1 minus x3 equals 1. Next, we're going to add row 2 to row 3 to finish our conversion to echelon form, which will lead us to receive ax3 equals negative 6 in place of negative x2 equals 3, due to these two canceling out. Don't forget to add these side numbers. Next, we're going to solve for x3 by isolating the fourth variable, the fourth equation. It's 2x3 equals 2, divide both sides, x3 will equal to 1. Using x3 equals 1, we can use the third variable equation, plug in 1, and solve for the value of a. Solving for a, we receive a equals negative 6. Now, the third equation implies that the system of equations is consistent for one value of a. Using the value of x3, we determine the value of a for consistency to be a equals negative 6.